get started on our first question on exam 3, which is wire length increasing or decreasing. It's all about the strain. So we're going to use the following coordinate system, and we're going to write out the strains and all the strain gauges in this problem. So for A, B, C, and D, we're just writing out the strain and the strain gauges. So let's start out with A to begin with. So in A, I only have, in my stress tensor, I have a stress in the 2-2 direction. And thus, I am going to measure here, my E sub 1 is going to measure a strain in the 1-1 direction. My strain gauge in the 2 is going to measure a strain in the 2-2 direction. And I know if I only have this component of stress, my E11 is going to be simply 1 over E times minus nu sigma 2-2. And my E22 is just going to be simply sigma 2-2 over E. So if I have those values, all I have left is just this. And I'm also going to, of course, with all of these, you also measure thermal strain, delta T, and plus alpha delta T. So that's it. That's all it is for this one. Again, we're just writing out the strain in each strain gauge. We're not looking for, your full total strain values as well. So that's all we've got here. So this is our sigma 2-2, and that's our solution. So we're just measuring strain in the 1-1, strain in the 2-2, just given by our values, again, from our equation 66 in the notes. So let's go ahead and look at B. So in B, I know that I'm just going to I have a compressive stress here. So I have a sigma 2-2. We'll worry about the signs later. I also have a stress in the 1-1. It's a little bit more complex stress state. But I know that the strain in the 1 is equal to the strain in the 2 is equal to the strain in the 4 direction, which is all going to be measuring the strain in the 1-1 direction, because they're all aligned with that 1-1 direction. And I know for this problem, the strain in the 1-1 is going to be equal to 1 over E times sigma 1 minus nu sigma 2-2. That's it. And I know that my for 3 is equal to the 2-2 direction. Strain in the 2-2 is equal to E times sigma 2-2 minus nu sigma 1. That's it. Of course, plus alpha delta D, just to be safe. And there you go for that problem. All right, now we get to something a little bit more complex here. I'm going to change my colors just for the fun of it for C. So here, now I have, right at the strain strain gauge, the bending in the black is going to make this sheet pop out of the page. So we're going to be extending the wires here, and we're going to be compressing the wires here because it's on the back of the page. So for C, I know that I have a stress in the 1-1 direction, and I know that my strain in the my first strain gauge is going to be measuring the strain in the 1-1 direction plus bending, because again, out of the page, so it's popping out, so those wires are expanding. So this plus alpha delta T. That's it. And I know that my epsilon 1 is going to be equal to my sigma 1 over E. There it is. Only thing difference now for the second strain gauge, still measuring in the 1-1 direction, but now it's minus EB, because again, those wires are being compressed because the sheet is popping out of the page. So plus alpha delta T. And again, these signs are going to kind of come out as long, once you apply, the stress. So once you're given the value, you'll figure out that this is, a negative stress. There it is. So finally, let's go to the last problem here and see what the question's asking us. Now here, we still have bending in the black is going to cause it to pop out of the page, but bending in the red is going to pop it into the page. So let's go ahead and kind of attack this problem one by one. So let's start with, I know that my strain in the 1 is going to be equal to the strain in the 2. I don't have any here. There's no kind of compressive stress, so we're just dealing with bending. So I know, for example, I'm going to change colors. The black component here, that is going to elongate the wires. That's going to be positive bending. And then now, let's go ahead and deal with the red. So if this pops it into the page, what's going to be kind of happening here to that strain gauge? If we're popping now that into the page, new EB, you can kind of see that if we're pushing it into the page and it's popping out, going into the page, we're going to be kind of compressing essentially the wires here, and they're going to expand. They're going to lengthen by some amount, new EB. Let's go ahead and look at the strain in the 3 direction. So For the strain in the 3 direction, let's consider the black first. So in the strain in the 3 direction, if we are popping out of the page and we're on the back, what's going to happen? Well, similar kind of idea, right? We're going to be compressed here, and that's going to cause our material to elongate. So we're going to be some positive new EB, the wires essentially. What about if we pop into the page? Well, if we pop into the page, that guy is aligned in that direction. We're going to be, as it's on the back, so if we're popping in the page, we are going to expand again by some amount, EB. And what about our old friend E4? So let's go ahead and see what happens there. So for 4, if we pop out of the page, we know that we're going to be compressing that directly, so it's going to be some negative EB. And if we pop into the page in that kind of, if we've been in that transverse direction there, what's going to be happening here? So if we're on, basically on the back, we're popping out, we're going to be elongating here, so we're going to actually contract some amount new EB. So that's it. That's all of the strain and all the strain gauges. So you might expect to see a problem, something like this could be definitely in play, but odds are on this exam, I'm probably going to ask something more quantitative. But it's important to kind of know these relationships, and specifically as we rotate, and especially when we're bending, we can increase or decrease by an amount, EB, negative EB, or this new EB. So kind of think about that. When we're in the state of pure bending, we don't have to kind of consider those other values. And of course, as always, there's this alpha t, all these as well. So make sure to include that on your problem statement, just for clarity. Even though it might not be stated, it's nice to kind of, if you don't see a change in temperature, you kind of neglect that later, but it's nice to kind of include this for a partial credit on your exam as well. So that's about it. Let me know if you have any questions, and good luck, and we'll get into problem 2 next time. Thanks. Bye.